Welcome to the second part of 8.4 compounding interest. Today we're going to talk about calculating present value given the future value. Okay, so we'll go through there, talk about some examples, talk about rounding on the calculator, and that'll about do it. So first, we've used the formula to compound interest to determine the future value of a present amount, but we also use them to determine the present amount needed to accrue to a certain future value. So the book kind of gives you separate formulas, but we can just manipulate the formula that we already know. We know that for future value, compounding certain amount of periods, n periods per year, we have P times 1 plus R over N to the NT. Well, to solve for the present value P, we just divide both sides by this 1 plus R over N to the NT. So we have our formula here, okay? If we're talking about continuously compounding or infinite compounding periods, all right, we're simply going to divide both sides by E to the RT, all right? So just make note of those two new formulas. And now we're going to talk about some examples, and one thing we need to note is that we are always going to round P up, okay? And we kind of talked about that the other day as well. So this first example, how much needs to be invested so that 40 years from now there's $50,000 in the account, all right? Assume the account earns 8.9% interest compounded monthly. So N is 12, R is 0.089, and our A is $50,000. So we're just going to plug that into our formula, okay, and throw it onto the calculator. Now, looking to the right, we get this answer over here on our calculator. But remember, to determine future value, well, let's look at which one we need to do. So on your calculator, what we can do is, let's suppose that we let P be, if we were rounding down, 1440.74. If we were to get that and throw that onto our calculator after 40 years, you're going to notice we're not quite at $50,000. But if we round up to 0.75 and throw that onto our calculator to figure out the future value after 40 years, we could see that we are over $50,000. So we want to make sure that we do round up, okay? This side is not enough, and this side is enough, okay? Otherwise, we wouldn't get to $50,000 after 40 years. So we round up, okay? And that's where we get that final answer of $1,440.75 needs to be invested now so that in 40 years we'll have $50,000 in the account. Let's take that same example, but now we're going to compound continuously. Okay, so that 8.9%, we want $50,000 in the account after 40 years. Okay, with the rate of 8.9%, and now we're using that continuous compounding formula where our future value is equal to E times the rate times, or E raised to the rate times time, and we're going to have to round up, okay? Because looking below, if we were to round down to 94 cents, we're going to see we're not quite at $50,000 in the account after 40 years, but if we round up to 95 cents, we will have that $50,000 in the account after 40 years. So make sure you are rounding up no matter what that third decimal is telling you to do, okay? We always round up. So now I want you to take a look at example 8 really quickly, and I want you to find how much money should be deposited today in an account that earns 7% interest compounded weekly. So if it's compounded weekly, N is going to be 52, okay, 52 weeks in a year, that will accumulate to $10,000 in 8 years. So our future value is $10,000. I want to know how much I need to put into the account right now. So go ahead, try the formula, and check back. Okay, so hopefully you got $5,714.25, remembering to round up. all right? And be careful when you plug into your calculator. Always use lots of parentheses if needed, okay? All right, so now we're going to move on to talk about effective annual yield and what that represents. So lots of different investment opportunities are out there. Some have higher rates, higher risk, some are compounded annually, continuously. So where do you begin to compare? One way is by computing how much is in the account at the end of 1 year, and then report the simple interest rate that would have yielded the same account value. So that's kind of going to lead us into effective annual yield, or effective rate, or simple interest rate. Is the simple interest rate that produces the same amount of money in the account at the end of 1 year as when the account is subject to compound interest rate. Okay, so we're going to compare simple interest to compounding interest. When we borrow money, this is typically called the annual percentage rate, or APR. You've probably heard that if you've ever bought a car or listening to car commercials, the annual percentage rate, APR. So the nominal rate is the stated rate. All right, so let's just get into this example. Let's suppose instead of $1, we're going to change that to $4,000 we deposit into an account that earns 6% interest compounded daily. So remember, we're going to use 360 days per year. So if we want to find the future value, well, remember that's P times 1 plus R over N to the NT. So if we're throwing that into this information, or that formula, we should get the future value is $4,247.32. Okay? Remember, we're not going to round up on the future value. So what's the simple rate, or what simple interest rate would you get, or would get you the same future value? So remember, simple interest is this formula, P times 1 plus R to the T, R times T. So we're going to use this future value from part A, and we're going to set it to the simple interest formula. So we've deposited 4,000 times 1 plus R to the T. We're talking about 1 year, so T is 1. So dividing both sides by 4,000, we get 1.0618 equals 1 plus R. Subtracting 1, we get R by itself, which comes out to be about 6.18%. So what this means is, if I was using simple interest, I would need to invest that at a rate of 6.18% to get the same amount that I invested at 6% but compounded daily. Finally, that leads us to our last formula for this section, is the effective annual yield. So that's equal, or Y is equal to 1 plus R over N to the N minus 1. So Y is the decimal form of the effective annual yield. R is the nominal interest rate in decimal form. N is the number of compounding periods per year. So a couple takes out a loan for a house for 5% compounded daily, 360 days per year. When they go to sign the paperwork, it says that the annual percentage rate is 5.13%. Why? Well, let's look at the formula for the annual yield, okay? Effective annual yield. So we have a percentage of 5%, so 0.05, compounded daily, and then we're going to subtract 1 from that. That's going to get us that comparison between the simple interest and the compound interest. All right? So when we do that and throw that into there, we get 0.0513. This means that the money invested at 5.13% simple interest earns the same amount in 1 year as money invested at 5% interest compounded daily. So it's just talking about comparing simple interest to compounding daily and how you would have to change that rate in order to get those values to be the same. If you have questions, let me know.